Hello and welcome back to Optimizing 2D Shapes lesson. So far we've talked about how to find the maximum area given a fixed perimeter, and we said that the maximum area rectangle with all four sides enclosed must be a rectangle in the shape of a square where length equals width. The maximum area rectangle when three sides are enclosed must be a rectangle where the length and the width are related by the equation length equals twice the width. And the largest area rectangle when two sides are enclosed is in the shape of a square where length equals width. And last but not least, the largest area triangle is in the shape of an equilateral triangle where all sides are equal. And we also mentioned that if we have all sides enclosed, the largest area is when the shape is the most symmetrical. So the most symmetrical triangle is an equilateral triangle, and the most symmetrical rectangle is in the shape of a square. So we took a look at a couple of examples, and we're down to example number 4. So let's get to work. A rectangular garden is to be fenced by using the wall of a house as one of the sides of the garden. So this is a house, and one of the sides of the garden is used as one of the sides, the house is used as one of the sides of the garden. And we need to enclose the three other sides of this garden. Now, we want the area of the garden to be 40 meters squared, and we want to find the minimum perimeter and the dimensions of the garden in each case. So we want the dimensions to be whole numbers, still in meters, but whole numbers, and the dimensions can be decimals. So we're going to get started with question A. So here we are, we have this beautiful garden, which I will highlight it. And we're only enclosing the sides that I'm highlighting in pink. So this would represent the length, and this would represent the width of the garden. And this must be width as well, obviously, because this is a rectangle. Now, we know that the area of this rectangle is length times width. And we know that the area is 40, and it equals length times width. Now, we want to find the dimensions that will give this area, okay, and minimum perimeter. So we will have to do some check and guess exercises in here. So we have 40 can be given as a product of 1 times 40, which means that the length will be 1, the width will be 40, and that will make the perimeter equal to, remember the perimeter is length plus 2w in this case, right? So 1 plus 2w would be 1 plus 2 times 40, which makes the perimeter 81. Another possibility is length being 2 and width being 20, which means length of 2, width of 20 will give a perimeter of 2 plus double 20. And that will give a perimeter of 44. So obviously the perimeter of 44 is smaller than 81. So as you can see here, for a length of 2 meters and W20, we have smaller perimeter. So let's continue searching for whole numbers for the lengths and the width. So number 40, or the area of 40, can also be expressed as 4 times 10. So we cannot do 3 because the width then will have to be a decimal number, right? So the next two factors that multiply to 40 and are whole number factors, right, is the pair 4 and 10. So that means length is 4 and width is 10. So that will make the perimeter 4 plus twice 10, and that will be 24. So obviously, as you can see here, the perimeter is getting closer. So I will continue with my strategy, searching for new lengths combinations, length and width. So another set of numbers that multiplies to 40 is 5 and 8. And again, we're looking for whole numbers, which means that length must be 5 and width must be 8, which means that perimeter would be equal to 4 plus 2 times 8, that's 16 plus 4, or 20. Now, obviously the perimeter is smaller, but what I'm going to do now is I am going to let the length be 8 and the width be 5 and check and see if I'm getting a better value this time. So in this case, we'll have the perimeter of, let me write this down. So length is 8 and width is 5, right? So the perimeter will be 8 plus 2 times 5, which will make the perimeter equal to 18. So we are getting an even smaller number. So continue on. Maybe we can get even a smaller number. So the next product that we can consider here is flip 4 and 10 to 10 and 4. So that means that the length is 10 and the width is 4. The perimeter in this case would be equal to the length of 10 plus twice the width of 4, which is 18. So notice how, as we were moving on with our factors, so increasing the first from 1 to 2 and decreasing the second factor from 40 to 20. And again, as you can see, we increase the lengths and decrease the widths, right? We notice a consistent decrease in the values of the perimeter. And the smallest perimeter that we've gotten so far is 18, and it repeated again when the dimensions were 10 and 4. So 10 for the length, 4 for the width. So it seems that at 10.4, we get the same perimeter as 8.5. So what I'm going to continue doing is the same strategy. See how 5.8, we flip them, right? And 4.10, we flip width and length. So I'm going to try to flip 2 and 20. So I'm going to write number 40 this time as 20 times 2, which means that length will be 20 and width will be 2, which will give perimeter of 20 plus 2 times 2, or 24. So as you can see, this time the perimeter increased. So the perimeter decreased, it remained constant, and then increased again. So if I continue using the same values like 40 and 1, and we can try that, there is no harm to it. So let the length be 40 and the width be 1, then the perimeter will be 40 plus 2 times 1, twice the width, or 42. So as you can see, the perimeter is increasing now. So what is the minimum perimeter we found, given that the length and the width were whole numbers? So we'll say that the smallest perimeter was 18. And that happens that when, so the perimeter was minimum in two different cases. When length was 8 meters and width was 5 meters, and when we let length be 10 meters and width equal 4 meters. And with this, we have answered question A in this problem. Now, next question is question B, and is asking to find the dimensions if we're allowed to use decimals. So this will be a fairly easy question to answer this time, because we know that perimeter is a minimum, or is kept at a minimum, if length equals twice the width. Why? Because we are here in the case when we have only 3 of the sides enclosed. So we're going to say that with an area length times width equal to 40, so area equals 40, if we substitute length by 2w, because that's the relationship we want between length and width to minimize the perimeter, times W, it means that 40 must equal 2 times W squared. Divide both sides by 2, and that will give 20 equals W squared. So to find W, we'll have to square root both sides. And that's how we get W equal to square root of 20. If you use a calculator, the square root of 20 equals 4.47. We'll round it to 1 decimal, so 4.5 meters. So W equals 4.5 meters. And length equals twice W, or twice 4.5, or length equals 9 meters. And to be more precise, I'm going to write 9.0 meters in here. The reason why is because this is a rounded number. And why is it a rounded number? Because we calculated it based on a value that we had already rounded before. So we're going to say that in order the length of the or the dimensions of the minimum perimeter rectangle would be length of 9.0 meters and width of 4.5 meters.